The company XYZ Electric is developing a system to avoid collisions. The system uses a laser to periodically calculate the distance between objects in front of a car. The fact that the streets are not always in perfect conditions, the estimation of the distance is not always correct, so we need to use a gyroscope to consider the angle of inclination of the car when we have to calculate the distance between this car and the object that is in front of it. The problem is to design a system that provides the best estimate of real distance to an object in the shortest time possible and without losing data of the sensors. To solve the problem with the calculation of the distance between the car and the object in front of it, a parent process was used, which will oversee handling the signals. Likewise, 3 other processes will be implemented. The first one will be the distance reading between the car and the object in front of this. The second one will be reading the angle of the gyroscope. And the third will be the calculation of the actual distance between the car and the object. All this is done to be able to handle with greater ease the different data obtained from the laser and the gyroscope. But likewise, it should be considered that the memory spaces for this process will be used, so it will be necessary to establish the amount of data to read by the process that performs the calculation of the actual distance from the car to the object. Because there is a gap between the measurement times between the laser and the gyroscopes, which causes the distance measurements to be made more frequently than those of the gyroscope, an average value of the laser measurements will be calculated. On this occasion, 20 measurements will be made, which are composed of the different parts of the angle of the gyroscope and the average value of the distance that originates in the laser. All these values will be used to calculate the real distance of the car with the ratio with the object in front of this one. As we mentioned earlier, the program will make 20 measurements, which we will use to get the different distance between the car and the object that is ahead. These values will be used later to validate the difference that exists between each of the measurements that are made in this process. As we can see in the following table, the values generated by the gyroscope are given in its hexadecimal. This does not generate any inconvenience since we can calculate the cosine with this respective estimated distance. And with this we can obtain the 20 readings that we expected to go measuring the distance between the car and the object that is in front of it. As we can see, the gyroscope can make positive and negative measurements, which can simulate the different inclinations that the car can have while it is in motion. The different measurements that are taken from the estimated average distance are between 10 and 18.3. All these data are gathered after all the transitions that are between the readings of the gyroscope and the laser. We have to remember that these two sensors operate at different times, so we consider to make an average in the values of the distance to take this value and make the operation with the angle, and with this we can get the distance. But what is always sought is to be as accurate as possible for this type of implementations. So the system is intended to be faster. Likewise, implement several sensors so that in case of any fails, the system can continue working. With all these measurements, we can perform the calculation of the actual distance of the car with the object in front of it. The difference between the estimated distance obtained with the laser with the actual distance to the object is not so great, but when we apply it into a security system for a car, we can represent a high improvement at the time of wanting to improve the safety of the driver that is using this car. So we can say that if we can implement more sensors in this kind of dispositive, we can make better estimation of the real distance. We can create a system that will not be able to fail in if any sensor has a problem. But in this occasion we are only using one gyroscope and one laser, so we have to validate this with signals to make this system very accurate. In conclusion, we can say the following. When the program is carried out serially, the data is obtained in a faster way. The problem of doing it serially could cause that if several sensors are implemented, if one of these fails, the whole system will stop working, which means that the solution is not scalable. To work with more sensors, it is necessary to modify the code, so we have to make it work correctly, and with this avoid having to make modifications whenever you want to add a new sensor, but you can simply add them to the system without having failures. So if we can make this code to work in a concurrent way, we can stay all the time with the same code, and we only have to add more sensors to the system.